Let us understand slope of a line. Let us draw a line L in the coordinate plane which forms two angles with the x-axis which are supplementary. The angle with the positive direction of x-axis is theta and the other angle is pi minus theta. The angle theta made by the line L with the positive direction of x-axis and measured anti-clockwise is called the inclination of line. Now we observe that the lines parallel to x-axis or coinciding with x-axis have inclination of 0 degree. The inclination of a vertical line parallel to or coinciding with y-axis is 90 degree. If theta is the inclination of line L, then tan theta is called slope or gradient of line L. The slope of line whose inclination is 90 degree is not defined. The slope of a line is denoted by small m. Thus, m equals to tan theta, where theta should not be equals to 90 degree. Tan theta is called slope or gradient of line L. Definition: if theta is the inclination of line L, then tan theta is called slope or gradient of line L. Let us take an example. Find the slope of a line which makes 120 degree angle with the positive direction of x-axis. Solution: here theta equals to 120 degree. Now slope of a line m equals to tan 120 degree, which can be written as tan of pi minus 60 degree, which becomes minus tan 60 degree, and which is equal to minus root of 3. Slope of a line when coordinates of any two points on the line are given. Let us take 2 points P x1, y1 and Q x2, y2 of non-vertical line which make angle Q with the positive direction of x-axis. From point Q, draw QR perpendicular to x-axis and PM perpendicular to QR. Now the angle PMQ equals to angle ORQ equals to 90 degree, and therefore PM is perpendicular to QR. Case 1. When the angle is acute, that is, theta is less than 90 degree, the slope of a line L equals to m equals to tan theta. But in triangle MPQ, we have tan theta equals to QM by PM. Thus we can write m equals to y2 minus y1 divided by x2 minus x1. Conditions for parallelism of lines in terms of their slopes. In a coordinate plane, L1 and L2 are two non-vertical lines with slopes m1 and m2 respectively. Let their inclination be alpha and beta respectively. If L1 is parallel to L2, then inclinations are equal. That is, alpha equals to beta. Hence, tan alpha equals to tan beta. Therefore, we can say m1 is equal to m2. That is, their slopes are equal. Conversely, if slopes of two lines L1 and L2 is same, that is M1 equals to M2, then tan alpha equals to tan beta. By the property of tangent functions between angle 0 degree and 180 degree, we can say that alpha equals to beta. Therefore, the lines are parallel. Conditions for perpendicularity of lines in terms of their slopes. The two lines L1 and L2 having slopes M1 and M2 are perpendicular if and only if M1 into M2 equals to -1. Please note that this is very important. Proof. If the lines L1 and L2 are perpendicular, then beta equals to alpha minus 90 degree. Therefore, tan beta equals to tan of alpha minus 90 degree, which can be written as minus cot alpha. Now cot alpha is equal to minus of 1 by tan alpha. Tan beta equals to minus of 1 by tan alpha. Now tan beta into tan alpha equals to -1, which can be written as m1 into m2 equals to -1. Hence, two non-vertical lines are perpendicular to each other if and only if their slopes are negative reciprocals of each other. No more. Conversely, if m1 into m2 equals to -1, that is tan alpha into tan beta equals to -1, then we have tan alpha equals to minus cot beta, or we can say tan beta plus 90 degree, or tan beta minus 90 degree. Therefore, alpha and beta differ by 90 degree. Thus, lines L1 and L2 are perpendicular to each other.